Anjali, and I'm a rising junior at Monte Vista High School. So for my project today, I've created this tabletop wanderer robot. And the reason I created this robot is because coming into this program, I knew I wanted to do something engineering related, but I wasn't quite sure what field. And as a rising junior, I kind of have to figure out my life before my parents spend thousands of dollars on my college education. So I figured this would be a good project to get me into what I might be interested in. So this project has a mix of like mechanical, electrical, and software engineering, so I thought it might give me a good gauge of where my interests lie. So I'll give you a quick demonstration of it. So as you can see, it's able to wander around the table without actually falling off. And the way it works is I have 4 infrared sensor modules on each of the corners of my robot. So these modules consist of an infrared emitter and an infrared detector. So the detector will detect if an infrared ray has hit it, and if a ray has hit it, that means that it has bounced off of the surface, so it's still on the table. If there's no infrared ray detected, that means that that part of the module is off of the table and the robot needs to move. So based on which modules have gone off the table, I've coded my robot so that it either turns, reverses, goes forward, etc., etc. So I've actually had huge difficulties with my infrared sensors, and I spent weeks troubleshooting. The first set of infrared sensors I used actually had a 2-pin detector, and that was effectively useless because they didn't detect anything. They gave me like wild ranges of values when nothing was even there. So I switched over to 3-pin detectors, but I still had issues with those. When I tried to switch from my breadboards and prototyping to actual circuit boards, I found out I was actually blowing out I wasn't blowing out my emitters, I was blowing out my detectors with the heat of my soldering iron. So I had to figure out a way to move around that. Even when I figured that out by using pin headers, I still found out that I was getting like ambient IR rays, so I had to figure out a way to filter that out through the use of capacitors and resistors. But overall, though it was a bit frustrating to figure out the infrared, it was really nice when I finally got it to work. But once I got it to work, I had issues with my chassis because that came 5 days later than expected, so I had to assemble it in 1 day and test it with my infrared on the same day. Even though this project has proven to be really challenging and somewhat frustrating, I found that it's actually taught me a lot about being independent and learning on my own. I've actually managed to narrow down what kinds of engineering I do. I'm probably not going to be as interested in electrical engineering because of all of the hardware issues I had, but I do find myself leaning towards more mechanical or software, especially software since it's much easier for me to bug fix my code and troubleshoot what exactly is going wrong, and I have a lot more tools available to do that. So, thank you. Are there any questions?
What is this 2-pin, 3-pin detector you speak of?
Okay, so the 2-pin detector, I don't know if you can see it, but it's somewhat like this. It has 2 legs. The 3-pin detector has 3 legs. And so the way the 2-pin detector works is that it basically gets power and it'll read in analog inputs, so you can get a wide range of values. Each of those values will correspond to distances that the surface is away from the robot. So if you get larger distances, that means you're likely over the floor instead of the table. The 3-pin detector is digital instead, so it only reads 1s or 0s. 0s means that the surface has been detected, 1s means that it hasn't. So that's a bit different, and also it has 3 legs instead of 2.
How many iterations of the IR sensor circuit have you gone through?
Not including the 2-pin detectors, I'd say at least 10 PCB boards.
Wow.
Including the 2-pin detectors, I'd say probably 13. Yeah.
And why did the final one work?
So the reason this final one worked was because I started using pin headers that protected all of my components from the heat that I was using. So I could solder in the pin headers, and then when everything had cooled down, I could put my actual components in. I also used capacitors and a resistor in series with some of my components, and what that did was that like filtered out other rays or IR rays that might have been detected in the environment, and it focused the emitter solely on what was being emitted from the IR emitter.
Nice. Quite a process.
Yeah, many iterations.
Right.
Is that all?